Page 492 in your textbooks. Your homework last night was to do the 2 through 8 even, as well as 11 and 12. Also, reading over what we're going to talk about today. So hopefully you took the time to do that, and that'll hopefully make today's lesson a little bit easier to understand. Page 290 or 492 in your textbooks. So there's 2 through 8, 11 and 12. 2 through 8, good. Excellent, very neat. Thank you. Good. Bueno. Good. Yeah, excellent. All right, number 2. Finding the first 5 terms of the algorithm, a sub n equals 3 times quantity n minus 3 plus 2n. And what did you get for your first 5 terms? Matt? Good. -4, 1, 6, 11, 16. And by the time you've gotten through the first few numbers, you should see the pattern of basically just adding 5 if you were to keep going. You also could have simplified the algorithm down and simplified it to a 5n -3. And that could have worked also. Number 4, we have a recursive sequence, 2 plus 3 times a sub n minus 1, given that a sub 1 is 5. What were those first 6 terms? They got big in a hurry. Audrey?
5, 17, 53, 161, 485, 1,457.
Good. 5, 17, 53, 161, 485, 1,457. And by the way, because one of the numbers has a comma in it, the 1,457, instead of using a comma to separate terms, upgrade to a semicolon. English class. All right. Number 6, finding the next term in the arithmetic sequence. We go from a 3 to a 1 to a -1 to a -3. What's the common difference here, Kendall? -2. So if we add a -2, it gives us our next term. -5. Excellent. Number 8, finding the 15th term of an arithmetic sequence. If the first term is 7 and the common difference is 6, what is our formula, first of all, for an arithmetic sequence? Abby?
A(n) equals a1 plus in parentheses n minus 1 times b.
There we go. A sub n equals a sub 1, and then we got the n minus 1 times the common difference. So we'll just plug in the numbers, right? The a sub n, since we're looking for the 15th term, becomes a sub 15. A sub 1, it said, was 7. And since we're finding the 15th term, 1 less than that, of course, would be 14 times the common difference, which they said was 6. And what did you end up with for the 15th term? 91 is correct. How many perfect on 2 through 8 the even? Any questions on 2 through 8 the even? Questions on any of those? All right, let's look at number 11, finding the series of 4i minus 3 going from 1 to 13. How did you split that thing up, Brandon?
4 times the series of I, and then subtracting from the series of 3.
There we go. 4 times the series of I minus the series of 3, and of course going from 1 to 13 in each case. All right, so for this, how do we set up this part right here, Brandon?
13 times 14 over 2.
There we go. And of course, all of this is going to end up getting multiplied by a 4. And then for this, how do we set up just this part of the series?
13 times 2, which is 30.
Yeah, that one we can do in our head. Your answer ended up being?
325.
How many got 325 for number 11? Excellent. Questions? Number 12, how do we set that one up? Genesis.
10 times 10 plus 1.
Okay, not asking for the plug, just how do we set up the actual series? Because we don't have a 5i squared series memorized.
Oh, I write it down in my head.
Okay.
10. Well,
What I'm looking for is 5 times the series of I squared. Just pulling the 5 out front. That was the question I was looking for. Pull the 5 out front for the series of I squared. And then how do I set up this part of the series? That's what you kept trying to tell me.
10 times 10 plus 1. Well, 11.
Which is 11. There we go.
And then 2 times 10 plus 1.
Which is
20.
all over 6. And of course, this 5 out front, you could essentially treat it like it was in the top or just leave it out front. What did you get for your answer?
1,925.
Excellent. How many had 1,925? Okay, any questions on 12? Read number 9 for us, if you would. It wasn't part of the homework, Michael. We're going to take a look at this one together because we hadn't talked about any of this, and we're not going to per se as far as notes go. It's a really easy concept, though. I just wanted to reference it to you. Michael?
Insert 4 arithmetic means between 5 and 80.
What does mean? I mean, you have to go all the way back in your brain to your pre-algebra days, but what does mean? It's the average. It's the middle value. Now, not the median. That's the true middle. But the mean is kind of the value that's in the middle. For instance, you get all kinds of different grades throughout the quarter, but at the end of the quarter, on the report card, we put the mean. All right, so here it says insert 4 arithmetic means between 5 and 80. 4 arithmetic means. How do you suppose, if you saw this on, say, an achievement test, never heard of this before, how do you think you would fill in the 4 numbers? Or would you just throw down a guess and move on with life instead of thinking it through? Hopefully you wouldn't. Hopefully you put some little thought into it. What do you think?
Divide 80 by 5.
Why?
Because they're the ends, so find the common difference.
Would dividing 80 by 5 give you the common difference?
Probably.
Does division give you a common difference? What about this? What if I had a 1 and a 4, and we needed the 2 arithmetic means? Would I divide 4 by 1? Because you know the next 2 numbers in this one, class. 2 and 3, obviously, right? So how do we figure that? Other than the fact that, it's easy. Mathematically, what would we do here? Yes, but how do you know we add 1? For instance, here we're not adding 1, right? Because then we get 5, 6, 7, 8, 9, 80, right? That doesn't sound right. How do you suppose we figure it out? I take it number puzzles are not one of our strengths. Okay, it's pure logic. That's the key. So this tells me a little something, but anyway. What's the difference between the first number and the last number, class? 3. How many times do we add to get from the first number to the last number? 3. So we have a total difference of 3, and we have 3 numbers to get there. So what's the common difference? 1. 3/3. 1. What's the difference between 80 and 5? I have to go 75 total to get from here to here, but how many different numbers can I use to get there? There's 4 numbers in the gap, but how many total times do I add to go from a 5 to an 80? 5 times. 1, 2, 3, 4, 5. So if I simply divide by the 5, what is the common difference? 15. So what are my arithmetic means? Does that make sense now that you've seen it? Again, the ideal would be you could figure it out on your own, but if you can't, does it make sense now? Figure out what's the total difference. How many numbers do I have to get there? That tells me the average or mean difference in the sequence. All right, you try number 10. There are only 2 arithmetic means they're looking for, between 3 and 129. What's the total difference, class? 126. How many found 126 is how far you've got to go? And divided by what number, class? 3, because you've got 1, 2, 3 chances to get there. So what's the common difference, class? 42. So my next number? 45, and then 87. Does it make sense now? Okay, not any notes necessarily, you're not going to be tested, quizzed on it, but again, it's a number pattern, and that's essentially how we figured that out. All right, next thing in your notes, this you will be tested and quizzed on. And this is what you read about last night, and you're reading a geometric sequence. A geometric sequence. An arithmetic sequence is kind of like what we see here. You just add. Or You could even add negatives, couldn't you? If the numbers are getting smaller instead of bigger. We saw that in one of the homework questions. That's an arithmetic sequence. You're adding to get to the next thing. A geometric sequence, here's your definition. Consecutive terms are related by a constant for a geometric sequence. Consecutive terms are related by a constant that is multiplied by each term. Consecutive terms are related by a constant that is multiplied by each term. Consecutive terms are related by a constant that is multiplied by each term. So where with a arithmetic sequence we add, with a geometric sequence we multiply. So we don't have a common difference that gets multiplied. We have a common ratio is what it's called. So we multiply by a constant that's called the common ratio. So mentally, you've got to keep these facts straight. Arithmetic, you add a common difference. Geometric, you're going to multiply a common ratio. For instance, if I started with a 5, and then I went to a 35, and then I went to a 245. What am I multiplying by here, class? A 7. So 7 would be the common ratio. Someone with a calculator, what's the next term in the geometric sequence? 15? Is that what you said? All right, and then if we wanted to do the next term, we'd multiply by 7 again, and that would give us 12,005. Now, y'all remember, okay, be honest, when you were little kids, and you got out the calculator, and you didn't even know what it did yet, but you found you could do like 2 times 2 equals. Did any of you ever do that with the calculator? Just keep hitting the equal button and watch the numbers change really, really fast? Okay, you never did.
I was literally just doing it.
You were just doing it, okay. Now, those of you who have a calculator like mine, I don't know if Michael's works that way or not, but go and do 6 plus 7, for instance, equals, and watch what happens. Nothing. A good calculator is designed to keep you from accidentally double hitting equals and screwing yourself up. Okay, so scientific calculators typically are designed so it won't do that to you. Does yours do that?
It does it if I do another plus 7 onto that, and then I can hit equals.
Okay, so you do 6 plus 7 equals, and it kind of tracks the change there. On this calculator, there is a way you could do this. You can do this for multiplication as well. It's above the hype key. So if you're looking at the TI-30XA, right above the hype key, there's a little K. K stands for constant. So you did 6 plus 7. Now before you hit equals, you did second function hype, which is K. You'll even notice a little K pops up in the corner of the screen. Then if you hit equals, you're telling the calculator, I want you to let me add a bunch of times. You should be able to do this with multiplication as well. For instance, 2 times 3 constant equals, and it'll keep multiplying by 3 really fast, and the numbers get, of course, really big really fast because you're now multiplying instead of adding. Okay, so hence the K function, and I've just lost my whole class. So Gavin will take just a moment. So anyway, what?
I can't figure it out.
You can't figure it out. Okay.
2 times 3.
Second function, because the K is what you're shooting for. The button says hype. We don't want the hype, we want the K. So second function K, and then equals. Yep. So anyway, you could, on your calculator, you could do that. You know, sometimes in life you make decisions, and after the decision you thought, that was a stupid idea. Why did I teach them that? Or why did I do that?
Every year.
Yeah, anyway. All right, so, so how about this one? What if I said 20, 10, 5? I'm clearly not adding or subtracting anything. What's the common ratio?
Divided by 2.
I'm dividing by 2, but remember, a geometric sequence, you always multiply, you don't divide. So when you say dividing by 2, remember, that's the same as multiplying by the reciprocal. So we wouldn't say the common ratio is a 2 or we're dividing. We'd say the common ratio is
-2.
the reciprocal, 1/2. You multiply by a half, multiply by a half. So if we multiply by a half, 5 times a half, class, is 5 halves. Multiply by a half again. 5/4. Multiply by a half again. 5/8 and a half again.
5/16.
And notice the fractions just keep getting smaller and smaller and smaller. So if you have a fractional or rational common ratio, your values will be getting smaller and smaller towards 0. If you have a an integer for your common ratio, it just gets bigger and bigger and bigger. Consider this for just a moment. 2, 4, 8. What's the next number, class? 16. Notice we're not adding something constantly, but we are multiplying by a 2 constantly. The next number? 32, because here our common ratio, class, is 2. What about this? 75, 15, 3. What's the common ratio? 1/5. Again, your natural brain says I'm dividing by 5. Turn that to a reciprocal, say you're multiplying by a 5th, and that actually makes it a lot easier on the next one. 3/5. 3 times a 5th. And then you can multiply that by a 5th. 3 25ths, and so on and so forth. What about this? 3, -6, 12, -24. What's the common ratio this time?
-2.
Notice we're multiplying by a -2, so hence we get a negative. But now you multiply by negative gives you a positive. Multiply by -2 gives you negative. So if we multiply by -2 again, class,
48.
a positive 48. Multiply by -2 again, -96. Notice that because the common ratio is negative, the signs keep bouncing back and forth. In your notes, you might want to copy that example down and just make the note. This is called an alternating geometric sequence. An alternating geometric sequence. Anytime the common ratio is negative. Anytime the common ratio is negative, you can have what's called an alternating geometric sequence. Questions on geometric sequence just in its simplest state. We'll talk a lot more in depth, here in a minute, but do we understand the basic premise? It seems like we do. Are there any questions, though? Turn your books to page 472. Turn your books to page 472. I want you to do 1 through 7, the odd. Page 472. I want you to do 1 through 7, the odd. By the way, how many before today had figured out your scientific calculator didn't let you do the equals equals thing before? You tried it and realized it didn't work. Some of you already knew that. How many of you are rushed to find that out just today? And now you know how to circumvent it. It'd be like a magic trick. You tell a little sibling, hey, do that equals equals thing on the calculator, and they try, like, it doesn't work. Sure it does. You take the calculator, put in the K. Yeah, see, it works for me. They'll never notice the little K in the corner, and that's an evil way to pick on younger siblings, if you're a nerd. Because only nerds play with calculators with younger siblings. I should know, I'm a nerd. Brandon's finished. By the way, have I shown you how to put fractions into the calculator? I feel like I have. Maddie, you're good with fractions? Okay. I knew last year in geometry I did. I was pretty sure I'd done that this year. Okay. So even fractional common ratios, we should be fine. Several people finishing up. By the way, I failed to mention this when I was giving you the notes, so you may want to jot this down. If you're ever struggling to figure out the common ratio, just like the common difference was term minus previous, common ratio is term divided by previous. So you're like, I can't figure out what the ratio is. Okay, take whatever, any term you want, well, not the first one, obviously. Take any term other than the first, divide it by the previous, and that'll give you the common ratio that you need. So on number 1, what is the common ratio? Maddie? 2 is the common ratio, so the next number in the sequence would be 208. Number 3, what is the common ratio? Genesis? Abby?
1/4.
1/4, because you take any number. Now, strategy tip. Don't take the big numbers. Go to the little numbers. Take 4 and divide it by 16 to get your 1/4. So what is the next number in the sequence, Abby?
1.
1. Number 5, going back to Genesis, what is the common ratio?
Well, negative.
-3, good, which means we're going to have an alternating sequence, though we could already tell that, right? We saw the alternating signs. What's the next number? Good, -1,215. Number 7, what's the common ratio here, Audrey?
-1/6.
Good, this is alternating, so we know we're going to get a negative, but it's also getting smaller, so we know we're looking for a fraction. It is -1/6, and so the next term in the sequence would be a +1. Anyone go get 4 for 4 on here? You got them all? All right, any questions on these? Any questions on these? All right. Next thing in your notes, just as we had a formula that we could use for an arithmetic sequence, right? A sub n times a sub equals a sub 1 plus n minus 1 times d. We're going to have a formula we could use to find the nth term. So, formula for nth term.
Does this go on our formula sheet?
It's going to go on the formula sheet. So notes first, and then we'll copy to the formula sheet as well. So we'll have it in here twice. For now, don't copy this next thing down. I just want to get you to think. If we had 2, 4, 8, 16, again, this is a really basic sequence. What's the next number, class? 32, right? We can easily see the common ratio, which we'll represent with the letter R, is a 2. Now, if I had the same common ratio, maybe I started with a 7, 7, 14, 28, 56, blah, 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 right? Okay, still a common ratio of 2. The key is to get the second term, we multiply the first term by the common ratio, correct? So a sub 2 is equal to the first term times the common ratio. We're all agreed with that, correct? If I want a sub 3, right, then I'm going to take a sub 2 and multiply that by the common ratio, correct? You always take previous term times that constant. But remember, a sub 2 is a sub 1 times r. If I substitute, that means that a sub 3 is a sub 1 times r, or we could say, class, times r squared. Do you see how if I multiplied not by 2 but by 4, I would go from 2 to 8? Multiply by 4, I could go from 7 to 28. Do we see that? If I wanted to find the fourth term, well, of course, any term is the previous term times common ratio. But remember, a sub 3 is a1 times r squared. So again, I could replace this with an a1 times r squared, multiplied now by r. Or in other words, class, we would get r cubed. Again, r is 2 in both cases. R cubed would be 8. So if I wanted the fourth term, multiply by 8. Multiplied by 8. Do we see that? If I want the second term, it's a sub 1 times r. Third term, a sub 1 times r squared. Fourth term, a sub 1 times r cubed. Notice in every case, the power of the r is 1 less than the term we're finding. Do you see that? So here's the formula I want you to write down. A sub n is equal to a sub 1 times r to the n minus 1. Whatever term you're looking for can be found by taking the first term and multiplying it by the common ratio raised to the n minus 1 power, 1 power less than what we're looking for. Put that in your notes and then also put it on your formula page. This should be formula number 9. Formula number 9 on your formula page. This is the geometric sequence formula. I believe we're to formula number 9, the geometric sequence formula. Geometric sequence formula. A sub n equals a sub 1 times r to the n minus 1. If I lost you on the background, I'm sorry. I think most of us probably got it. Maybe all of us hopefully got it. But the main thing is memorize the formula. Find a term, take the first term, multiply it by the common ratio raised to 1 power less than the number of the term you're finding. Look back at page 470 now. Look back at page 470. Look at example 10.4d. It says, find the formula for the nth term in the following sequence. 10, 30, 90, 270, 810, 2,430. We just want the formula for the nth term. So a sub n equals, well, what is a sub 1 in the first example problem class? 10. So 10 is my a sub 1 times r to the, well, since I don't know what the n is, I just say n minus 1 power, but what is the r? What is the common ratio being used in this geometric sequence? A 3. 10 times 3 gives 30. 30 times 9 times 3 gives 90, and so forth. Or take any number, divide by 3, you should get the 3. So the formula here is a sub n equals 10 times 3 to the n minus 1. Easy enough? The only things you can plug in, if you don't know n, you can't plug anything in. But you know a sub 1, and you know r. You plug in the numbers, that's all there is in the first example. Questions? Look at the next example. Read it for us if you would, Brandon.
Find the formula for the nth term in the following sequence. Use this formula to find the 8th term of the sequence. -16, 8, -4, 2, -1.
Blah, blah, blah. All right, so we first want the formula for the nth term. So we'll say a sub n is equal to, what do I plug in for a sub 1 class? -16. And then I'm going to find the r. What is the common ratio in the example problem? -1/2. Take any term, preferably the last two they give us, because they're the easiest numbers, make your ratio out of them. -1/2 obviously gives us a -1/2, and we're going to raise to the n minus 1 power. Do we see how to get the formula? Do we also see I couldn't multiply and say 30 to the n minus 1 or +8 to the n minus 1 because the exponent would have to come before multiplication in order of operations? You couldn't simplify this anymore, just wanted to point that out. So it says find the 8th term. So a sub 8 is equal to -16 times -1/2 to the 8 minus 1, or class the 7th power. What is -1/2 to the 7th power, anyone?
-0.00.
No, I don't like decimals. Give it to me as a fraction if you could. -1/128. Questions on that? Now, multiply that fraction that should already be on your calculator times -16. And what is the 8th term in the sequence going to be? Careful. Times -16. Negative times negative on your calculator should have given you a positive. +1/8. And that's my 8th term. Questions on how to use the calculator for this? Any questions? Flip over then to page 472 again. So flip over just one page. Let's do number 9 together. Number 9. And they give us the first few numbers, 2, 14, 98. What's the common ratio here, Kendall?
7.
Good. Common ratio is 7. Obviously, the first term, a sub 1, is
2.
2. So my formula for the nth term is going to be what, Kendall?
2 times 7 to the n minus 1.
Good, and they said they want us to find the 6th term. So now let's find a sub 6 specifically. That's going to be 2 times 7 to the 5th power. Do we remember from earlier in the year how to raise to a power on our calculators? Forgotten, you might have a caret button, or if you've got the TI-30XA, it's the y to the x button up here, right above your division sign. You do 7, hit the y to the x button, 5, and it equals. And that'll give you 7 to the 5th, a very big number. Then multiply that by 2. And what is the 6th term of this sequence, which starts out looking not too bad, right? 2, 14, 98. But by the time you've gotten to the 6th term, it's what massive number, Kendall?
33,614.
On your calculators, if you haven't already, plug it in. You should get that number. If you don't get that number, raise your hand and have me come help you. How many? Raise your hand. You have it. All right, so everyone's good to go. If you're watching on YouTube, you're struggling, let me know and I'll find a way to help you with that. All right, let's take a look at number 11. We want the 7th term of the sequence, 6, negative 42, 294, negative 2058. Things are spiraling out of control in a hurry. What's the form? Well, first of all, what's the common ratio? Genesis? -7. And obviously a sub 1, the first term is 6. So what's the formula for the nth term, a sub n?
7, no. 6 equals.
No, a sub n equals a sub 1, which is 6, times the r, that's the -7, to the n minus 1. Does that make sense? You're just going to plug in these two values in the a sub 1 and the r spot. But they want us to find which term on number 11.
Oh.
Yes.
7.
The 7th term. So we're specifically going to find a sub 7. Well, that doesn't change the first term. That's still a 6. And it doesn't change the common ratio being a -7. But it does tell me what exponent we want right here.
6.
The 6th power. So at your seats. Genesis is going to get us the answer here in just a moment. It's a dilly. What do we get here for the 7th term? And it's already looking pretty nasty anyway. It should have upgraded to semicolons, by the way. But what is the 7th term, Genesis? 705,894. How many have that? Now again, if it's not too far, you could just multiply by -7, that gives you the 5th term. Multiply by -7 again, 6th term. Multiply by -7 one more time, it gives you the next term. You can even use the constant button to do it. But again, if you wanted the 23rd term, you're not going to want to do that. So, get good with using the formula. Number 13, they give us the formula -18, 54, -162, 486. Okay, when we go to set this up, the first thing I need to know, class, is what is the... Well, first term, of course, is -18. And what is the common ratio? Class? -3. Then we're going to set up the formula. I'm going to come back to Genesis here. For a sub n, we just drop in the numbers.
-18 times
Good. But on number 13, Abby, we want the 10th term. So we want a sub 10. So we're going to plug what into the calculator here in a moment?
Equals -18 times -3 to the 9th.
Good. But on the calculator, order of operations, the first thing we should plug in, class, -3 to the 9th, then multiply by the -18. And what do we get for our answer here, Abby?
354,294.
There we go. Questions on number 13. How many got that answer? Do we feel comfortable using the formula to find any term? Again, find the common ratio first, then plug it into the formula. I want you to do 15 to 21, the odd. 15 to 21, the odd. And that's page 473. Yes, sir.
How do we do 21? It confused me.
Oh, well, we're not there yet, but you find the common... Okay, notice the comma isn't separating terms. Semicolons are.
Oh.
Yeah, that's what threw you off. You were thinking of 3 as the first term, 125 is next. It's a 3,125. Hence, semicolons versus commas. Very important. English class wins again. Evidently, somebody's been working ahead. I can't lose to Abby. I can't. Finished?
And when am I going to turn 21 into a fraction?
Yeah, you're right. Even the textbook has this as a decimal. Yeah, good point. Yeah, number 21 is, because the denominator is too big, they only give you, I think, 3 digits or 4 on a calculator for a denominator. Michael's may give him a fraction.
Yeah.
Yours did? Okay. It could give you a fraction depending on the calculator. TI-30XA is going to give you a decimal. Though, I'll show you how you could turn it into a fraction on the back end, but I'm not usually that dedicated, just to be honest. Gentlemen, just waiting on the ladies.
How do you turn it into a fraction?
You don't on this one, you leave it as a decimal.
For 17.
For 17? Oh. Okay, so quick refresher on this. Usually, to turn a fraction to a decimal, see at the very bottom the little arrow key. Up above it, it says F to D. So the second function goes fraction to decimal. So if you do like 0.56, second function F to D, it'll give you 14/25. Or if you plugged in, 5/8, second function F to D, it'll give you the decimal. So that's how you bounce back and forth. In fact, you just keep doing it. And let's keep going back and forth between fraction and decimal, unless, as Brandon noted, the denominator is too big. Then it'll only leave you with a decimal on this particular calculator. Michael sits triumphantly with his Casio that can make it a fraction. All right. Well, let's take a look at these. Number 15, what is the 7th term of that geometric sequence, Maddie? 17,496. Obviously, first term 24, common ratio 3. You're going to raise that 3 to the 6th and then multiply by the 24. Number 17, what is the 10th term there, Abby?
It's still decimal. 184.
181. 181st. You're actually correct the first time. 181st is correct. Or as a decimal, it was something really small. 181st. 0.0. Ooh, this is cool. 0.0. 1, 2, 3, 4, 5, 6, 7. Now it rounded the last digit to a 9, but it's actually an 8, 9, and then it just keeps repeating. So it's really cool repeating decimal there. But 181st is the fractional answer. Number 19, we have an alternating geometric sequence, and it's a big, well, little technically, number for the 7th term. What did you get, Michael?
We're on 19.
Number 19.
106, 29366.
So negative, did you have negative or positive?
It is positive.
Oh, it should be negative. Yeah, 7th term is going to wind up being negative because all the odd terms, 1st, 3rd, 5th, 7th, 9th, and so forth, are negative. So negative 10,629,366. Commas help to read the number there. And then number 21, Brandon, it gave you what decimal?
0.00032.
Good, 0.00032. In our calculator, the TI-30XA won't make this a fraction. But if you really wanted to, because you can't stand for Michael to have a leg up on you, figure about your place value. Tenths, hundredths, thousandths, 10,000ths, 100,000ths. This is 32 100,000ths. We clearly see we can divide a 4 out of top and bottom, right? Which if we divide on your calculator, if you need to, 100,000 divided by 4.
250,000. No, 25,000.
I'll say 25,000. Well, there's still a 2 I can take out, so let's take out a 2 and get 4 over 12,500, right? Take out another, actually I divide both of those by 4. So 12,500 divided by 4 gives us 3,125. And that's the equivalent. That's why the calculator wouldn't do it at a 4th digit in it. That's the fraction you had.
Yeah.
It's a lot easier on yours, admittedly, but we could, or we could leave the 0.00032 like even the textbook did, and that'll be fine as well. I don't believe I do anything like that on a quiz or test to you. Similarly, something like number 14. Let's take a look at that, shall we? Number 14. Let's do it together. We want the 100th term of the sequence, 3, 9, 27, 81. So we're going to plug a sub 100 class is equal to 3, the a sub 1, times 3, the r to the 99th power. Now the answer is going to come out really weird looking on your calculator. Do the 3 to the 99th power, and what pops up on the screen? Scientific notation, 1.717 blah, 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 times 10 to the 47th power. Then we have to multiply that by 3, times 3. And so we should end up here with a weird looking answer, but it's 5.153 blah, 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 times 10 to the 47th power. Do we see that on the calculator there? All right, questions on that? Yes, sir.
Could you just do 3 to the 100th power?
I suppose technically here, yes, 3 to the 1st times 3 to the 99th. I mean, you're multiplying like bases, add the exponents, type in 3 to the 100th power. It would give you the same answer. Yep. It won't normally work that way, which is why I didn't point it out, but you're right. Good. Good algebraic observation. Good. Any other questions on 14? I want you now at your seats to do numbers 2, 6, 10, 18, and 22. 2, 6, 10, 18, and 22. We pretend like we're teaching geometric sequences. Really, it's just calculator practice. Just a reminder, we have a test coming up next week. I believe it'll be 5 lessons from today. The matrices on there. So tonight's a light homework night for you guys. I'd spend some time looking over matrices, refreshing your memory now. So when we start reviewing in a few more lessons, it's not the first time you've seen it in 2 weeks.
What does this mean?
97 degrees, and that's just pure degrees, no 0 minutes, 0 seconds, 0 fractions of a second. It's a way of measuring angles. You'll learn in geometry next year. It's not nearly as complicated as you think.
I don't know how we do that.
Well, I know how you did that. You accidentally hit second function equal sign. Everybody wants to hit second function equal sign. All right, for sake of time, let's take a look at our answers here. Now, number 2, we did not need a formula. All we had to do on number 2 was figure out that the common ratio is what? Genesis? Number 2.
I don't write it down. I just
Oh, somebody help class? 4. All we had to do is figure out the common ratio was 4, multiply 1 time by a 4, and we move on with life. Our answer for number 2 back to Genesis is good, 3,328. Number 6, what was the common ratio, Audrey? -7, and then we just multiply by the last term they gave us to get the next term, which is? Good, negative 9,604. How many good to go on 2 and 6? Number 10, we come to the formula. They want the 8th term. Obviously, first term is 11. Common ratio here, Maddie, is 3. So we plug it into the formula, we get? 24,057. How many had that answer for number 10? Number 18, the 6th term of, and they start with really big numbers. They get small very quickly. And what is that 6th term, Michael?
1/6.
I know what you did. Remember, raised to the n-1 power, not to the n power, the n-1 power. So you raised to the 6th power, should have raised to the 5th power. Brandon?
1.
Just 1. Should have been the 6th term. For redemption, number 22. What did you get for your answer, Michael?
149.
There we go. 149th is correct. That time raised to the 7th power. How many got 18 and 22 correct? Are there any questions at all on those before we dismiss? All right, well, no homework this evening other than, again, it's still a little ways out. You know, I'm not giving the definite date yet, but it's going to be next week, mid to late week. Matrices, don't forget to look those over. But no written homework. Have a wonderful rest of your day, and you are dismissed.